Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Modropic Lines by GraphZol81. And here are the rules. We have standard Sudoku rules apply. Place each digit 1 through 9 once in each row, column, and 3 by 3 box. A digit in a gray cell is either smaller than all digits in orthogonally adjacent cells if the arrows point inward, or larger than all of them if the arrows point outward. So this would be larger than all the cells that share an edge with it, which is what orthogonally adjacent essentially means. So this must be greater than all 4 of these cells. But this cell is smaller than all the cells that share an edge with it. So it must be smaller than all 4 of these cells. And these are minimum maximum rule set. Every line in this puzzle is both entropic and modular. So any set of 3 consecutive digits on a line contains a small digit, 1, 2, or 3, a medium digit, 4, 5, and 6, and a large digit, 7, 8, 9, and a digit from each of the sets, 1, 4, 7, which is 1 mod 3, 2, 5, 8, which is 2 mod 3, and 3, 6, 9, which is 0 mod 3. So every set of 3 digits on these lines are both entropic and modulo. Interesting. Cells with a V between them contain digits whose sum equal to 5. Okay. That is interesting. So, for example, if this were, say, a 3, this would have to be a 2, because these 2 digits must add up to 5 because there's a V in between them. This is interesting. I've never done anything which combines both modular and entropic lines in the same line. So this should be interesting to see. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. First things first that I see is we have 2 V's in box 1. So this must be a combination of 1, 2, 3, 4. Well, the interesting aspect of that is that means the rest of the box cannot be 1 through 4. So on this line, it has to be 5, 6, 7, 8, 9. Well, that means on this set of 3 digits, one of them must be low. So this one must be the low one here. So this cannot be 4. This is 2, 3, or 4. 1, 2, or 3. This is 2, 3, or 4. That means this is a low digit here. This digit must be greater than 3 other cells on this line. 3 consecutive cells on this line. So it's definitely higher than a high digit. So this has to be 8 or 9. So this is definitely high. One of these 2 is high. So since this is high, this has to be low and medium here. This digit, we don't know about that. Okay, so this digit is smaller than at least one low digit. So this must be 1 or 2. So this is blue. Same with this. This is lower than at least 1 low digit because there's 3 consecutive digits here. So this must be 1 or 2. Because this is smaller. So then these are medium and high. And these are medium and high. So this is at least 2 mediums here. So this must be at least 6. But we don't know. It's 6, 7, 8, or 9. So this is medium, or high also. This is 1 through 4 to add up to 5, so this is low or medium. And 3 away would also have to be low or medium. This is low, 1, 2, 3, 1, 2, 3, 1, 2, 3, so this is low, which makes that a 3. So this cannot be low here, this is medium or high. We have 1 that's going to be low or medium here, so this cannot be low or medium here. This is 1, 2, 3, so this is medium or high. 1, 2, 3, so this is medium or high. This digit is going to be greater than 3 other digits, so this has to be 8 or 9 here also, which means this cannot be 8 or 9. So this digit, no matter what, is going to be 6 or 7, but it has to be greater than these two. So this cannot be high as a digit. So this is medium, this is medium. This cannot be medium, this cannot be medium then. This is a high digit, which makes this low and medium. This is 1, 2, 3, or 4. This is also 1, 2, 3, or 4. So these are low. Oh, we have a 1, 2, 3, 4 quadruplet in column 2. So that means the remaining digits in column 2 are 5 through 9. Okay. So this is low or medium. That makes this low or medium. 1, 2, 3. That makes this low or medium here and low or medium here. So one of these two is going to be low also. Interesting. So one of these is medium, one of these is high. One of these is medium, one of these is high. 3 eliminates 3 from being here, so this can't be 2 then, correspondingly. One of these digits here is going to be medium, because we have 3 consecutive digits here. So that means we have 3 medium digits already in box 5 in these 2 cells and one of these. So this cannot be medium. This is low. This cannot be medium. That's low, which means this can't be low. That's medium. And this can't be low. That's medium. Okay. One of these digits is going to be low. So we have 3 lows already accounted for in box 5. So these have to be high digits. And then obviously this is low, medium, or high. We're not sure which. Okay. Remaining digits in box 1 are 5 through 9. Okay. Oh, since this is 3, this cannot be 0 mod 3s here. Because again, it's both entropic and modular. So this cannot have a 6 or a 9 here. Therefore, as a medium in one of these 2 cells, it has to have a 5. So we're guaranteed a 5 here. Since this is guaranteed to be 5, this cannot be 8 with it, because 8 is 2 mod 3 and so is 5, so this must be a 5-7 pair, which eliminates 5 and 7 in the rest of the column. So no 5-7 here, no 5-7 here. That's interesting. This set of 3 digits cannot contain 6 and 9 for the same reasoning. If this were 8, this would force this to be 5, but then this set of 3 digits would have the same modulo set. So this cannot be 8. It's 5 or 7, which means this has to be 3 also, right? Because these are 1 modulo 3 and 2 modulo 3, which means we need 0 modulo 3. So that's 3 and 2. Same with this. This has to be 3 also, I think. So this cannot be 3 here, which means this can't be 2. This can't be 2 or 3. This is a 1-4 pair. This has the same problem. Cannot be 6 or 9. If it's 8 here, then this would be 5. So this has to be 5, 7. I think that forces this to be 5, 7 all along here, right? So this is 5, 7, 5, 7, 5, 7. And this is 5, 7, which eliminates 5 and 7 in the rest of the column. This can't be 3, so this can't be 2 here. Interesting. 3 in row 3 has to be one of these digits. Remaining digits in row 2. You can have 1, 4, 6, 8, and 9. Huh. Interesting. This must contain one digit that's 0 mod 3. And this must contain one digit that's 0 mod 3. So both the 6 and the 9 are accounted for in rows 5. So this cannot be 6 then. This has to be 7 is a high digit. And so this 7 means this cannot be 1 mod 3 because that's 3 away. So this has to be a 3. So this is 3, this is 2. This is not green, so this is blue. This is blue. That means 3 has to be here because it must be the 0 mod 3, 3. So this is 3. This is 1, 2 as a pair. We sort of, well, I don't know. We didn't necessarily know that. This has to be medium and is 5, right? Because we have 1 mod 3, 0 mod 3. We need 2 mod 3 as a medium. So this is 5, which forces this to be a 4, 6 pair here. This is 8 and 9 as a pair. That leaves this digit as a 5 here. So this is medium, cannot be high. So this is medium, and this is medium. So this cannot be medium. This must be low. So this is 1 or 3, which is next to 2 or 4 here. Therefore, this is not medium. This is low, not medium, and not medium. So this is 2 or 3 here. We're not sure. 3 obviously can't be there anymore. 5 eliminates 5 here. So this is 7, which makes this 5, which makes this 5. That makes that 7, which makes this not 7. This is 5, 7, 5. 7. Those cannot be 5 or 7 here. One of these digits is low. And so it has to be... Does it have to be low? Yes, actually. 2 cannot be here. 2 cannot be here because 2 was in the boxes and it can't be here. So one of these is 2, which means this cannot be low here. And you can't have 2 mod 3 in the rest of the line. So 8 can't be along here. Whereas 8 has to be one of these 2 cells, which means this can't be 8. This is 9, which forces this to be 8. 8 can't be in the same modular line as 2, or its modular set. So this is 1, this is 2. And this must be, so this is medium. We have medium. These are high. This is 2 mod 3, 0 mod 3. We need a 1 mod 3 as a medium, so that's 4. Therefore, this is 1 mod 3, 2 mod 3. We need 0 mod 3, so it's 6, which forces this to be 5. This is 5. 2 is one of these. We cannot have an 8. 8 has to be one of these. So what do we have left? 6 and 9 are the possibilities for here. And those are both 0 modulo 3. So this can't be 0 modulo 3. It's 4, which makes that medium. So this must be low and high. So 4 is here, which means this can't be 4. This can't be 9 because of the 9 here. So this has to be 6, 8 as a pair. It forces this to be 1 over here. So this is 1 and is low. This is 1 or 3. This is 1 or 3. We have 1 or 3 here. This can't be 2. So that forces this to be 3 here. So then every thing on this line, every low on this line is 3, so that's 2. We need a 1 mod 3 on this line. You cannot have 7, you cannot have 1, so this has to be 4. And then we have to have a 0 mod 3, which is high. So this is 4 and 9, which eliminates 4 and 9 in the rest of the box. This 8 eliminates 8 here, so this is 6 and 8. This can't be 6 or 8, it's 9. This 2 eliminates 2 here, so this is 1, which forces this to be 2. This has to be 7 to correspond to a high mod 1. So we have low here. Oops. These are all the 7s are high. 2 eliminates 2 here, so this is 9, which makes this 2. So this is high. This is low. 4, 9 pair eliminates 4 here, so that's 1, which makes this 4. So this is medium, low. This is high, medium, high. Okay. This is 1 mod 3, so this cannot be with 4, so this is 6, which makes this 4. 6 is 0 mod 3, so that makes this 8, which makes this 9. 8 eliminates 8 here, so it's 6 and 8. 6 forces this to be 8 here, so this can't be 8 here. This 6 eliminates 6 here, so this is 8, and this is 6. That forces this to be the last high, so that's 9, that's 8. So again, we have high, medium, low, medium, high. This has to be a 1-4 pair. We don't know where. That means we need a 2 somewhere. That means this is 5 here. We need a 2 and a 9 remaining in row 7. This can't be 9 because of 9 in the column, so this is 2, which makes this 9. So we have low and high. That leaves this digit as a medium and as 4, and this digit as 1 as a low. So the 4 here eliminates 4 here, so that's 9 and 4. That's high, that's medium, which leaves this as low. So this is 1. We still need a 2 and a 6 in column 1. 2 can't be here because of 2 in the row, so this is 6, this is 2. That leaves 4 and 9 in column 3. This can't be 9 because of 9 in the row, so this is 4, this is 9. We have remaining in row 8, 2 and 9. 2 can't be here because of 2 in the column, so that's 9 and 2. Remaining in row 9 are 6 and 8. 8 can't be here because of 8 in the column, so this is 6 and 8. This 6 eliminates 6 here, so it's 1 and 6. This 1 eliminates 1 in the column, so it's 4 and 1. Remaining digits in column 7 then are 4 and 8. 4 can't be here because of 4 in the row. So this is 8. This is 4. That leaves this as 1 and this as 6. Yeah, these Modropic lines are pretty restrictive, right? Once you have a set that you have on it, it has to be the same digit, essentially, right? So I don't know how much you can actually extend this rule set, because it's very restrictive once you get the scenario, right? I don't know. This is an interesting thing to try out, though. So, fun little puzzle. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.